Welcome to the course Basics of Biomedical Instrumentation. Here we are going to concentrate on fourth unit, which is measurement of non-electrical parameters. The main objective here is to learn about the different measurement techniques that are used for measuring non-physiological parameters. Also, to learn about the principles of operation of various equipments which are used in measuring the non-physiological parameters. In this lecture, we are going to see about temperature measurement. The term temperature is actually non-electrical parameter, and hence this temperature measurement is non-electrical parameter measurement. Then what is an electrical parameter measurement? For example, I can say ECG, that is electrocardiogram, EEG, electroencephalogram, and EMG, electromyogram. So these are all examples of electrical parameter measurement. Why they are called so? So what is actually ECG is? It is nothing but recording a biopotential signal that is generated due to activity of the heart muscles. So what is EEG? It is also the biopotential signal that is generated due to activity of the brain. And then what is EMG? It is also a biopotential signal that is generated due to electrical activity of the muscles. So we are recording the biopotential signals. So actually we are recording some voltage. So these are called what? Electrical parameters. Whereas this temperature is a non-electrical parameter, and hence this measurement is called as non-electrical parameter measurement. So what are all the other examples that I can give for non-electrical parameter measurement is blood pressure measurement, that is BP measurement, and the next one is respiratory rate measurement, and I can also say blood flow measurement, that is in which direction the blood is flowing or in which velocity the blood is flowing. So these are all what? Non-electrical parameter measurement. In the forthcoming lectures also we'll be dealing only with non-electrical parameter measurements. In this lecture we are going to deal completely with this temperature measurement. Let's go into our topic. This body temperature is actually a good indicator of a well-being of a person. So the well-being of a person can be decided with this body temperature. If the temperature of a person is high, what we can say, it is called as fever. Okay, so usually there are two basic types of temperature measurement that is being carried out in a human being. One is systemic temperature measurement and the next one is skin surface temperature measurement. Okay, so first we'll see about what is meant by systemic temperature measurement. This systemic temperature measurement is nothing but the temperature of internal regions of the body. So it is very important. It is not the temperature of the external surface. It is actually the temperature of internal regions of the body. How the systemic temperature is being measured? So this temperature can be measured with the help of some temperature sensing devices. This temperature sensing devices will be placed in a mouth or under the armpits or in the rectum. The systemic body temperature can be measured with the help of mercury thermometer. So we can encounter this mercury thermometer in our day-to-day life. So with the help of this mercury thermometer, we can record this systemic body temperature. This thermometer is usually inexpensive and easy to use. And moreover, this thermometer is sufficiently accurate to record the temperature. And the normal systemic human body temperature is 37 degrees Celsius, or we can say 98 to 99 degree Fahrenheit. If the temperature exceeds 99 degree, then we can say this condition as fever. Next we'll see about skin surface temperature. This skin surface temperature is actually a result of some kind of balance. So let's see what this balance is due to. Usually, whenever there is a blood circulation in some region, then there will be heat generated in that region. And this heat generated will be cooled by conduction, radiation, convection or evaporation. So simultaneously there will be heating and the cooling, and because of this balance between the heating and the cooling, there will be a temperature, and that temperature is called what? Skin surface temperature. In order to record the skin surface temperature, the patient must remain in cool ambient temperature, and one more important condition is the region over which the measurement is made must not be covered with any clothing. And the normal skin surface temperature ranges from 30 to 35 degrees Celsius, or we can say 85 to 95 degree Fahrenheit. Now we'll see about measurement of systemic body temperature. Whenever continuous recording of a temperature is not required, that is, the temperature can be recorded for a particular instant of time. It cannot be recorded for a longer period of time. So in that cases, we can go with the ordinary mercury thermometer. Whereas whenever the continuous recording of the temperature is necessary, that is, if the person is being hospitalized and the temperature must be recorded for a longer duration, then we must need some sophisticated instrument, and in that case we must need some greater accuracy also. And the two important electronic temperature sensing devices used are, the first one is thermocouple and the next one is thermistor. So first we will see about thermocouple. So in a thermocouple, we will be having two dissimilar metals joined together. So what we'll be having if we join two dissimilar metals? We'll be having two different junctions. Okay, so one junction will be placed over the surface where the temperature has to be measured. So the first junction will be placed over the surface where the temperature has to be measured. The other junction will be maintained at a constant temperature, and that temperature is called reference temperature, and that junction is called reference junction. When the temperature changes at the surface where the recording has to be made, then voltage will be created, and that voltage will be proportional to the temperature at the junction. That is, the generated voltage will be proportional to the temperature at the junction where the measurement is made. So this is about thermocouple, and the next one is thermistor. So this thermistor is nothing but a semiconductor element whose resistance will vary according to the temperature. So we have seen these two types of temperature sensing devices being used here, but of these two temperature sensing devices, thermistors are more frequently used than the thermocouples. The reason why, because is the thermistor is having greater sensitivity. Okay, and the problem with the thermocouple is it is very difficult to maintain the reference junction. And the resistance of the thermistor at some given temperature T1 can be determined with the help of this equation. RT1 is equal to RT0 e power beta into 1 divided by T1 minus 1 divided by T0, where RT1 is the resistance at temperature T1, RT0 is the resistance at a reference temperature T0, and E is the base of natural logarithms. Beta is the temperature coefficient of the material, and it usually is in the range of 3000 to 4000. T1 is the temperature at which the measurement is to be made, and T0 is the reference temperature. So next we will see about disadvantages of thermistor. Also, we are preferring thermistor over thermocouple. It has some disadvantages. Now let's see what are those. The first one is the non-linear characteristics. So thermistor have a non-linear characteristics. In order to overcome this problem, we must use some special linearizing circuits. And the next one is there will be some error induced due to the self-heating of the thermistor. So in order to overcome the self-heating problem, we must reduce the amount of current that is used to measure the resistance of the thermistor. So by limiting the amount of current, we can reduce this self-heating problem. And the next problem is the possibility of hysteresis. So this happens due to magnetization and demagnetization of the material. And the last one is the characteristics of the thermistor may change because of aging. So these are all the disadvantages of thermistor. And next we will see about the thermistor probes and the important characteristics of the thermistor probes. So this is actually how the thermistor probe will look like. So let's see what the probe is actually is. So this probe is nothing but the interface from the site from where the temperature is to be measured. So it is actually used for interfacing. So let's see the important characteristics of the probe. The first one is the physical configuration of the probe. This physical configuration includes size, shape, and flexibility of the probe. Depending upon the application, we have to choose these things. And the next one is sensitivity. It must be able to detect small temperature changes. And the next one is absolute temperature range over which the thermistor is designed to operate. So it is very important to choose this absolute temperature range, but it is not a problem in recording a temperature in human body because human body temperature is much limited. And the last one is resistance range of the probe. The resistance of the thermistor probe is available from few hundred ohms to several mega ohms. So resistance of the probe can be chosen according to the temperature range of interest. So this is all about systemic body temperature. Now we'll see about skin temperature measurement. So this skin surface temperature measurement can be done with the help of small flat thermistor probes that is placed over the skin. But we have some problem here. Why? Because this presence of the thermistor might affect the temperature over that region. So in order to overcome that problem, this skin surface temperature can be measured with the help of measuring the infrared radiation. So usually a human body can emit infrared radiation. Actually, the human body is a perfect emitter of infrared radiation. So let's see how it has been recorded here. So if a person is allowed to remain in a room at about 21 degrees Celsius, and the very important thing, and the region over which the measurement has to be made must not be covered with any clothing, then a device which is sensitive to infrared radiation, what will do is it will read the surface temperature. So here the skin surface temperature is proportional to the amount of infrared radiation that is being emitted. And the device used here is called infrared thermometer. Now we'll see about thermograph. Here you will be having an infrared thermometer which is incorporated into a scanner. So this scanner, what it will do is it will scan same way as a television camera scans an image, but it scans in a slower rate. So as a result, what will happen? It will produce a map of infrared energy on the photographic paper. That is, the recorded infrared energy will be mapped on the photographic paper so that you will be getting an image like this. So in this image, if you see here, you will not be seeing the legs here, right? So you can find legs in this image, but you cannot find the legs here. So what is the reason is, so this is actually the artificial legs. So these are the artificial legs. Since it is the artificial legs, it cannot able to emit the infrared radiation. So that is why you cannot find the legs here. The next one is thermovision. This thermovision is moreover similar to the thermograph we have seen before, but the difference is here the image can be shown in a real time on an oscilloscope. That is, you can see image in a real time in an oscilloscope while scanning the subject. And another important advantage of this thermovision is you can enhance the image while scanning the object. Finally, this skin surface temperature is used to locate breast cancer and used to find the region of poor blood circulation. This is all about temperature measurement. Thank you.